we distinguish between the different components of the spatialization. We have what we call the direct sound component, and then there are the early reflections, and then we have a sort of a reverberation tail simulation.
Hey everybody, Dave Lindberg in Hong Kong with a new episode of the THD Podcast. Today we have a couple gentlemen joining us from Denmark, from IDUN Audio, and they're doing some spatial audio processing for headphones. So it's kind of a topic du jour. It's getting popular, so we're going to find out what they're doing. But without delay, let's give a shout out to the Audio Express magazine, one of our, partners, promotional partners. So we encourage people to subscribe to that publication and also maybe look in the history and see what else you can find out about IDUN in the archives from Audio Express. And also the Alti Association. They're going to be at the high-end show in Munich in May, so we encourage people to go say hi to Barry and the Alti people during that event. So without delay, let's say hello. We have Ivan in Denmark and Pauli in Denmark. How's it going today, guys?
Yeah, really well. Thanks a lot, David. Thanks for inviting us.
Okay,
it's so we got it's great to be inside.
All right. Yeah, so we've got the CCO, Chief Commercial Officer with Ivan, and Pauli's actually the founder and the CEO. But also we got our co-host there in Japan, Simon, who's been working in headphones pretty much his whole life, so I'm sure he's interested to find out what you guys are doing with Spatial. So why not?
Very much so.
Yeah, let's have just a quick intro on how long you guys have been doing this and what kind of products you guys are offering for people.
Okay, so maybe I should start. So I've been working, almost 30 years now with spatial audio in different ways. And founded IDUN Audio 6 years ago. And so what we do is we focus specifically on embedded applications, so running the spatial audio in the headphone. And so we are 10 people here in Copenhagen, and we are just about distributing that to many different applications that Ivan can say a little bit more about.
Okay. Yeah, so my name is Sandager, Chief Commercial here at IDUN. Been on board for about 2 years. Got about 15, 17 years kind of aging myself, but 17, 18 years in the audio industry. Worked on some of the hearing aid companies here in Copenhagen. Joined Grossheimer Brayson that does test and measurement equipment. So did that for about 10 years. Had a fairly short stint with Knowles Electronics out of Itasca. Was there for almost 3 years. So kind of been all around those industries. And a couple of years ago, Eden or Pauli called up and said, hey, we kind of need someone to talk to our customers the way they want to be talked to and kind of represent us worldwide. You want to get on board, and had a couple of demos and kind of got hooked by that technology and kind of see where everything's going. And I think, so my job is to make sure that we kind of keep a presence with the brands, that we keep a presence with the manufacturers out in China, the chipsets manufacturers and all that. So my day pretty much starts with WeChat in the morning and then ends with calls on Zoom and Teams and all that in the evening with the Americans. So it's good. It's good fun.
Okay. So maybe we should jump into a presentation. We can supply some visuals for walking people through the intro.
Sure.
Yeah, thanks a lot. So as I mentioned, we work with spatial audio, and that's really exclusively what we focus on. And the key thing is that there are many ways to implement spatial audio. It can be, for example, run on a computer or on a smartphone. It can run on the operating system. It can be part of a gaming engine. But what we have decided to do is to focus really at the end of the audio chain. So running embedded inside headphones themselves. And the big reason for that is that we can get extremely high spatial audio quality because we avoid latency, especially latency going through Bluetooth. And another big advantage is that when the embedded solution runs in the headphone, the end users get a very consistent experience. So no matter what device they connect to, the headphones can always spatialize and can give this consistent experience.
Is that a product of just the power of edge processors advancing over time?
I think to one extent it is, yes. So when I started working on this technology, as I mentioned, in the 90s, we were running on very large gaming computers and having very clunky magnetic head trackers and things like that. So definitely signal processors have advanced enormously during the last 20 years. And so that's one thing. And the other thing is that we have actually done a lot of improvements to make the spatial audio run with extremely low processing power and then also a very low memory, so that we can actually run the processing inside the wireless headsets and also true wireless earbuds. So I think that's part of the story. But I think the real reason why we feel that it's important to run the spatial audio embedded is because of the head tracking. So head tracking is really in essence what makes the spatial audio work very well. And I think it's sort of intuitive if you think about virtual reality, that it's not it's unthinkable to have a virtual reality or an augmented reality headset without tracking. It's really, if you have an object in front of you, that object really gets its property of being out in space by the fact that you can move. And the same thing happens with hearing. So we feel that, spatial audio is not a new topic. Making sounds around a listener wearing headphones is really something that has been around for, maybe 30, 40, 50 years. But the thing is that when we do not have interaction in the acoustical space, in the virtual acoustical space, then all sorts of problems occur, like the sound being perceived too close to the head, back confusions, which are very well known, cone of confusion errors, but also just the sound being blurry in general. So the main point is that, the head tracking is a key factor. And what that means is that the head tracking has to be extremely fast and precise. So, making a movement and then updating the audio accordingly is really the key thing. And that can be done very well when the actual tracking is in the headphone together with the embedded processor. So if we do need to send the tracking through some kind of radio, so send it through Bluetooth, for example, then we inherently get way too much latency and the sound becomes unclear and blurry.
I think the other thing we can talk about is that, like you mentioned, that some of these chipsets on the embedded chipsets on the headphone, they're getting more and more powerful, allowing us to have more and more processing power. Obviously, when we look at the spec sheet for a headphone, we look at how much battery time am I going to get. So we always get squeezed by the manufacturer saying MIPS and memory, you have to go down. But in reality, we are actually quite efficient. And with the Chinese manufacturing and the Taiwanese manufacturing partners that we have, they're like saying, this is the solution that we go with because it allows us so much more MIPS and memory for something else that you also want ANC, ENC, and all that stuff. So I think that's where we really have our core. And then, of course, the customers that we talk to are the ones that don't have a phone in their offering. So everyone looks at Apple and says, I want an Apple phone. I want what they have. And we say, well, unless you can call up Tim Cook and ask him for access to the iPhone, everything they do runs on the phone, and then you have things going back and forth, and that's kind of what you're up against. And what we consistently see is we can match the performance of anyone in the industry. And as you'll see later, we've got a tuning tool that will allow either manufacturers or brands to design kind of their own setups, their own systems. So it becomes a tool that they can work with. And then at the same time, because this head tracking is really where Pauli has kind of found the gold grail. Maybe we're kind of giving away too much now, but that's really where once you have that, your spatial audio awareness and your awareness of where sounds are coming from is really, really increasing.
So I think we really dove into the deep end here. So maybe we could just take a little bit of a step back to kind of look at the fundamental idea.
Okay.
And I think so for us, we look at humans and the fact that we have developed this ability to hear in real life where sounds are coming from, how far away things are, what kind of acoustical space we're in. But when using traditional headphones, we have basically taken the signals that are typically designed for loudspeakers and put them directly into the ears. And because that doesn't contain the spatial information, the sound collapses and the sound image is really inside the head. So yes, there can be a left-right panning dimension to it, but basically the whole of the audio image is inside the head. And that doesn't happen anywhere in nature. So, this unnatural listening situation is really something that is tiring to the mind. And then over and above that, we have started to use headphones more and more during the last, let's say, 15 years. And especially also during Corona, right now we're sitting in an online meeting. And, having this wrong image, it just, taxes the hearing system, but also, creates a cognitive load at the end of the day. And so, we have developed a platform that can be used for many different applications for providing the spatialization in headphones. And, the idea really for us is not to make some kind of wow effect or, some kind of gimmicky feature. It's really just to allow the headphones to allow the end users to be able to use their natural hearing whenever using headphones. So what we hope is in 10 or 20 years, we'd look back and see all headphones having this ability, and we'll sort of look at each other and say, wow, did we really go around with sound inside the head? That obviously isn't right. So as you can see on the small... Yeah,
sorry, but is there, just so we understand, is there a trade-off between it's not like you're digesting a Dolby content or something like that that's like pre-programmed to have spatial location of whether it's a game, a movie, or a music, that the players or the characters are in locations. You're actually processing and synthesizing this on the edge?
I think, there are many different kinds of content that you are also alluding to. And so what we have to do is obviously to try and, provide solutions for all these different kinds of content. So if we do get something like a multi-channel signal that has, let's say, placements of loudspeakers, then we can simulate that audio system. But even today, by far, the most content is, of course, in stereo. And therefore, that is a primary playback situation. And what we do there is typically to simulate a pair of stereo loudspeakers in front of the listener. So we use what we call a physics-based approach, which is that we literally think of the sources being as loudspeakers, and that there is a physical listener, and that there's a room with walls, with reflections, and we simulate all of this. And in that way, it's also very intuitive to work with the system that we have created. But I can show a little bit more of that later.
Would it be fair to say there's kind of two components that we're talking? One is the localization, that is where your head track, when you move your head, and the other part is to simulate a room environment with speakers.
Yeah, certainly. Although I think this is all integrated, we distinguish between the different components of the spatialization. We have what we call the direct sound component, which is, of course, just the simulates the flight from a certain source to the two ears of the listeners, and there we have to simulate the actual listener and how the sound interacts from different directions. And then there are the early reflections, which have to be modeled quite precisely, and there we have a mirror image model, that can also is interactive. So as the listener and the sources move, the reflections also can move. And then we have a sort of a reverberation tail simulation, which is more of a recursive process. So I think these are relatively well-known concepts, but we have just worked very much with implementing them so that they can run at extremely low power on the embedded devices.
Okay.
So maybe we could just go a little bit further. Even maybe you could say a little bit more about that.
So what we see today, like I mentioned, is that the customers that come to us are the ones that are not kind of entrenched with a phone brand, or actually the phone brands that do have an audio presence that are saying, well, I don't know what my customer's going to have that in their pocket. They might have my phone, but they also might have something else. So I'm gonna launch something that I believe in is going to be a high end product, and I want to make sure that whatever you got in your pocket or your phone or your connecting computer will source that product. And I think what we see is that we're going to see a larger portion of the headphones have some sort of spatial audio component, and then I think what we're going to see is more and more customers are going to expect that to work across your products. So if I'm on my PC right now, when I go back home and I turn on my iPad and I want to be on that, I want to have a sort of special, I want an experience that I'm used to, and that's why we see that road going forward, and also means that we can enable any content that you kind of put towards our engine. So if we get a multi-channel signal, then we can handle a multi-channel signal. If you do, like Dave, you said, what about Dolby Atmos? Well, if we get access to Dolby Atmos signal, then we can work with that. So we can basically work with whatever is put out as right now. This technology is kind of holding us back because, like we said, we're working on Bluetooth. It's two channels. That's kind of where we are in the market right now. So yeah, what we see is, for the past, it's been dominated by phone manufacturers that put out something that was on their phone. Then you had to buy whatever headphone was associated, and then have whatever particular software that supported that. But what we see more and more, I think the last Qualcomm State of Sound kind of said the same thing, that people are kind of going towards the direction where I've got a preferred headphone, and I want that experience to go with whatever I listen to, whether it's a TV or whatever. And that's kind of where we see things moving as well.
Yeah, and I guess that the LE audio protocol, when actually we have it on phone and headphone side of the link, that could be a big game changer for the amount of data and what you're able to send over the air. And I don't know if I was dreaming, but is Bluetooth 7 announced before even 6 was? There's like another high resolution standard that's already been plotted by the SIG.
Yeah, I think absolutely right. I mean, I think technology and these groups are moving. I think we do love that LE Audio has come on board, kind of focus on this. And I think for up until now, the focus has been on higher bitrate streaming. But basically, we're looking at saying, well, maybe we could look at that bit stream and say, can we do like a 5.1? Let's say that you have like 6 speakers that you do transfer, which means that you will have a true experience, fully head tracked. That's some of the stuff that we're looking at right now with some of our friends and seeing, could we use that bit rate to actually open up for a multi-channel? And the bit rate is there. I mean, it's just a matter of how do you handle it on both sides. And I think that's the whole trick here, is how do you handle it on the transmit and the receive side.
Yeah, I spoke with the sales guy from Geely chipset in Shenzhen last week, and he says,
Yep.
we've had it for 3 or 4 years, just no phones have it. So
that's it. And I think that's the whole bit. And I think what we try to see is what are the caveats, where the market where we could do that and just say, look at a Nintendo Switch, where you do have a multi-channel input, you do have a USB connector. What happens if you connect a dongle and then you've got a low latent connection between the two that allows you to transmit multi-channel? Well, you own both sides of that. I think that's the next step that we will see, kind of that this market is going for.
Okay, yeah, gaming seems to lead everything nowadays, doesn't it?
I think consumers' willingness to pay for the hardware that they buy, because it either gives them an edge, they feel it gives them an edge, or it gives them a certain whatever you want to brand in that gaming community, means that they're willing to pay more for these kind of products. I think is intriguing for some of these brands to kind of let that be the leading driver for technology. I would say, though, we see more and more of our customers leading in those directions as well, saying, well, how can we do that? We're opening up connections. Unfortunately, I can't name the brand, but with a Chinese brand that says that's got both a commercial side and a gaming side, to go, well, would a 7.1 be possible where they basically just cable it? And then we do all the processing in the head, have that fast head tracking, and that seems to be something that's interesting to them.
Okay.
Yeah. So I mean, what we have is the base product that we have is we've got an embedded algorithm that runs on the chipset, whether it's Qualcomm, Iroha, Bestech, whatever that might be. Synaptics, you go mention. We work with them. Obviously, they are all kind of rely on kind of the core elements of either ARM or Cadence. So we kind of rely on that being present and kind of work from that, and then kind of help people build that in. And we've got these, I don't know if that's going to be the other way around. So Qualcomm demo headphones that they've been kind enough to send to us. So we demo on this platform when we do True Wireless. And there's a brand, I'm not going to mention who it is, but there's a brand that has put a spatial audio product into the market on the same platform. And they run at about 7% or 7 times more battery consumption running spatial audio compared to what we do. Basically doing the same solution, being embedded on the headphone, providing that solution. So when we say it is really, really low power, we can back that up with some pretty impressive numbers. And then afterwards, let's look at the tool that we've used. I think that's one of the things that really do cater to, especially the R&D folks, that they see that. I mean, all the audio companies we've worked with, they've got a certain, we all rely on a Harman curve. We all rely on a Knowles curve, whatever that's going to be. But we all have golden ears. Ours is Pauli, and he certainly has a way of thinking that things should sound a certain way. But all the companies have golden ears that have a certain tweak that they want to do. And that's what we allow them to do and say, what you want this and this and this to do, and how much do you want to prevent the users for? Do you want the users to have a user interface that allows them to switch between high reflection, low reflection? Do you want them to look at really externalization? I mean, if you're into church music and you want to sit in something with a lot of reflections like you used to listen to, then great, then let's create that. If you want something that's close to your head with a lot of bass, then let's do that. So that tool is really there for you to expose and express the brand that you want.
Okay.
This is you.
Yeah, so I think I mentioned a little bit before that, we use a physics-based approach. So there are different ways to implement spatial audio, but I think we find it most useful to really look at all the elements in the spatial environment as actual objects that you can move around. So our implementation is made very flexible so that these sources can move in real time, the listener can move in real time, the room can be changed in real time, and all transitions are very smooth. So it's really made for a kind of augmented or virtual reality implementation. And so I wonder if it's not maybe a good time to, show the tuning tool. So on the previous slide, Ivan showed that, we have on the one hand the embedded implementation that runs in the headphone. So all spatial audio processing happens in the headphone, but then the embedded platform has a very large API that can be controlled from a smartphone or from a computer for that matter. And I think that's where the power lies, to be able to set it up for different playback scenarios. Yeah, so I'd just like to show here our demonstration unit. So basically it consists of a headphone here, where this is just our way of making a wireless headset. It's an analog headset with a processing unit on top and a power bank and a Bluetooth dongle. And then, we can communicate to this through a smartphone. So I've got my smartphone here connected, and you should see the interface on the screen. So this unit also has a head tracker built in. So that's basically an inertial measurement unit that then, consists of an accelerometer and a gyroscope, and sometimes also a magnetometer, depending on, whether you want to do virtual reality or augmented reality applications. So as I move the headphone around, you can see the head of the avatar also moving in the virtual space. So that doesn't mean that there's any processing happening on the phone. We're just sending the head tracking down to the phone for visualization purposes. But so while listening to the sound, then, so what I show here is what is a scene that's set up for music playback. So it looks very much like a room, with virtual loudspeakers in front of them, and these speakers can be moved around, and so the idea being that when you listen to this with the headphones, the sound is clearly outside of your head, in front of you, and you get the classic sound stage when listening to kind of, Blumlein stereo, basically not hearing the left or right loudspeaker, but you hear the sound being panned between left and right. And then, we can, as I show here, move the listener as well. But also the room can be changed. So, for example, here we have what we call a large wet room, or a large dry room, or maybe like a medium room that's quite neutral, or some kind of small room. And clearly, we can by changing the properties of the walls, we can set up a sound studio sound, or a concert hall sound, or whatever somebody would prefer to listen in.
Can I just for everyone to know that this is our tuning tool. This is the one that engineers on our side, as well as the customer side, or the ODM for that matter, work with to set up exactly. So we don't expect kind of end users kind of swooping their head around. I mean, you can do that. And in demos, we love doing that. We kind of swoop you around the speakers, and people go, whoa, wow, that's really fast. But this is basically to kind of set up that particular solution that a customer want for them. And that's kind of what we help them to customize. And by the way, that becomes their property. So whenever they've done a tuning, spent time, spent money, doing that, then that is what they then go into the market with. That we don't share that with anyone. That those are their settings.
Yes, exactly. So this is really, as Ivan saying, this is what we call the tuning tool. So it's for us and for engineers at different companies. So using these three different elements, so the listener, the sources, and the room, we can set things up for example, movie listening or gaming, or for a podcast, for example. But also another whole area of playback that we find very useful is just setting it up for communication, for phone calls, for example. So again, somebody taking phone calls all day, having the sound inside your head is very taxing, but just placing the sound outside, like in a normal conversation, so you hear the person in front of you, and as you move your head, you hear that clearly outside of your head. And then also also you hear them in a subtle room and hear your own voice in that same room. That really gives that feeling of being together, making it much more natural. But that whole idea can also be extended to an online meeting. So I think, in Zoom we have individual channels for the different participants, and these channels can be streamed to the different talker positions. So while in a meeting, in principle, a listener can be moved. You can be switched off, and so the playback system or the online conferencing system, can control the placement of the sources. And I think why this is important is that we are used to having online meetings where all the audio is really in mono. So we have all the talkers inside our head, and we've become used to that and made an adaptation. So we do what is called turn taking, which is we give each other space to say something. But when we're around a table, people talk on top of each other and they interrupt each other. Or even if we take that to an extreme where we're in at a party or something like that, there are a lot of competing voices. And we as humans have this ability to focus on who we want to talk to or with. And that's due to the fact that the different signals are in different locations. And so by providing that also in the digital domain, when we have online meetings, that just makes for much more natural conversations. So I've shown, for the in the entertainment section here, a bunch of 2-channel playback systems, and that's typically what we use when we have Bluetooth. But our engine is fully prepared for other kinds of setups. Like, for example, if we have some kind of multi-channel setup, like a 5.1.4 surround, then we can place the sources here. For testing, you can move the sources around. But also, this is a 3-dimensional space. So, the speakers can be moved around up and down as well. And or if we're in a gaming scenario, for example, like this, let me just try that again. Yeah, so here we have a gaming scenario where we have multiple sources around the listener in the 7.1 surround. So what happens there is when the game outputs the signal in the 7.1 surround, that's of course sent to individual loudspeakers. And so if there is sound in the game from behind, you'll hear the sound from behind. But I think, that in itself is not new. There are plugins for games that can actually spatialize like that. But I think having the fast and precise head tracking, really also helps. So if you have a sound from behind and you make a small movement, you really can distinguish that it's behind you and not in front.
And just to make a note on that, like when we talk to gaming companies, very quickly the discussion goes on: do we want head tracking? I think Simon, you mentioned as well that like the IMU sensor, what is it? What do we use it for? And obviously, the IMU looks at which direction are you going. It's a BOM cost increase. It's I don't know how much it is. Let's say it's $70. It's $1, whatever that might be. So that's something that you have to make a conscious decision about. Does it add value? And you're in a game, and sometimes you see these professional gamers, their faces like on the screen to make sure that whatever delay there is between the screen and their eyes, if we minimize that, we want low latent mouse and all that. And I think what they're seeing is they're trying to see, well, people don't look to their back. They don't see all that. But what we actually, in the gaming section, what it's about is that you do these micro movements, which means that if you're in a first person shooter and that your enemy steps on a branch or something, that little crack will give you an auditory effect that is very, very precise on where it is if that head tracking is in the sub 30 millisecond sector. So it's actually still looking at the screen in front of you, but you want those micro movements to make sure that you can pinpoint very, very exactly where that sound is coming from. So again, these are some of the discussions that we're having, and there's a fair bit of education that we also have to go through with these companies and say, well, yes, it's head tracking, but it's actually more increasing the awareness and increasing the ability to pinpoint sound sources.
So it is possible to make an implementation without an IMU, but just not recommended.
It's definitely possible. Yeah, definitely. But as I mentioned, we are strong proponents of actually having the interaction, because we really believe that it gives very strong cues about the sounds around the listener. I think sometimes we do hear people saying, I want the spatialization, but I don't want the head tracking, which in our view is a little bit of a flawed idea. The head tracking, the fact that we move our heads in the real world, is really helping us to make sense of the space around us.
And to what extent does the headphones' underlying acoustic performance influence the effectiveness of spatialization?
The most important thing really is to be able to control the sound at the eardrum. So if I think, if we go back 15, 20 years ago, there were enormous differences between headphones, where some were giving us a nice broad frequency response, and we could really discuss how the headphones were equalized. And there were also headphones that were almost, if you look at their frequency response, it's almost just a resonance, But these days, I think a lot of relatively high quality headphones, which are the ones we're working with, all have extremely much improved sound quality. So I think, we do take care of or care about the style of headphone, but we've made the engine so that it's independent of the actual playback system. So, if you set up a room or you move, the sources or whatever, that same scene should be applicable no matter what kind of headphone it is.
Would there normally be a kind of calibration process for headphones? Like a unit by unit calibration?
In principle, there can be a calibration, but the approach that we've taken is that headphone manufacturers have typically gone through a lot of pains to actually equalize their headphone. And in fact, they often have strong opinions about what the headphone should sound like. And we don't want to change that. So what we've done is to make the spatialization neutral to whatever equalization is there. So going from the actual spatialization to a bypass where there's no processing, you shouldn't hear any coloration change. And that's, I think, something that has taken a long time to develop, but we see a lot of appreciation for that in the market.
Okay. And you just mentioned
can I just add a comment to that, Simon? Because I think that was the golden years way of looking at it. I think when you move into on the commercial side and marketing, sometimes they would like to have something where there's a bit of more of a wow effect, or you've got a bass boost when you turn something on, and the whole engine is built for that. The marketing can have those tools as well, or the end user can say, I can go in and do some of these tuning. So from a core perspective, we say have as little effect on the frequency response as possible. And then if you as a brand choose to say, we want like a super mode, or we want to do something, then you can add that effects on top of it. And a little anecdote is we had a brand that shipped us some. I mean, typically they want us to help them do the tunings and do the integrations on the chipsets, and we do assist in that process. And they sent us an early prototype, and we put the engine on. We tried to do that, but the bass just wasn't there, and we're like, this is not good. I mean, what? This is just like. And then they sent us a new tuning. Oh, by the way, we did the tuning now, and then all of a sudden, like, wow, the whole thing came to life. Like, okay, there it was. So we can do wonders on any frequency response, but if you haven't gone through the time of doing the tuning, then on the overall frequency response, then I mean it's hard to add spatial audio in terms of something that doesn't sound right.
Yep. Okay. Next thing I was curious. I think you mentioned already this can be used in TWS earphones.
Yeah, sure.
That's not immediately obvious how that's possible.
Yeah. So I think that this is really our reason to be, So it's not easy to make an implementation with all this functionality running in true wireless earbuds. There are also, additional challenges that are not in over-the-head headphones, such as that the left and the right earbud have to communicate with each other, and that the head tracking has to be in sync. And so there we heavily rely on all that kind of technology. So the head tracking is a very big part of it. But of course, the number of sources being simulated is not dependent on the number of loudspeakers in a headphone. So in that sense, it's not different from any other headphone.
I think very much we go where the market is, and I think for a very long time that the true wireless market was the growing market, and people wanted something that was as small as possible. The drivers had to be 6 millimeter and 5.8, and that was kind of a chase to how small can we make the speakers. And what we've seen in the past couple of years is that you've seen brands go towards a bigger driver, having like a bass driver, and then a BA to do tweeters or do something else, or the XMEM stuff. So I think there's definitely a move towards having these driver systems kind of support this. And I think that next big thing is going to be spatial audio, that they want that included as well.
Excellent. It's more of from a technical point of view.
Frontier that we're going to see are the guys that want in glasses. So where you want that whole auditory system, where we see more and more, I think these Ray-Bans by Meta, whatever that's going to be, where, I mean, I'm old enough to have Instagram, but I'm old enough to not really know what to do with it. So I think that you're supposed to take a picture and then you upload that. And I'm like, I probably just want to listen to my podcast walking down the street. So I think a lot of those that buy those glasses actually do that to engage with the world while they're still kind of enjoying their content. And for that sound to be in the middle of my brain, I've tried a couple of them at CS last year, and that was really strange to have that be open, be all around me, and then someone talk to me in my brain. Whereas adding that kind of front focused gives you that possibility of adding a lot more natural kind of feel to it. And then the future possibilities in this are just enormous. Just imagine that you walk up to a storefront, you look at a certain thing that you might be interested in, you could basically ask and say, what am I looking at? And it will tell you that, well, you're looking at this picture, you're looking at this product. By the way, it's on sale if they've got a promotion, or it could be a picture, could tell you something about who's that artist, who painted it, when was it done, is there a price point you want to buy it? I mean, it could be anything. So I think that's kind of the next steps that we see coming on board on this technology. And I think that's why we see so much engagement right now in spatial audio.
Mm-hmm. Yeah, so this engine, I think, is really, the way to think about it is that it's an object-based engine. And therefore, it is really prepared for virtual reality. So just to kind of show you here, if we just put it in this mode, then it is really, you see the room that you're in. Yeah. The engine can directly interact with smart glasses. Maybe just to round off this, talk about the tuning tool, which is an essential part of our offering, obviously. But there are a lot of deeper settings for when doing the tuning, for looking at the movement tracking, the input, the sources, the direct sound, early reflections, reverberation, tail, things like that. So, and in each of these, there are a lot of settings that can be tuned. For example, here for the reverberation tail, but also output equalization and things like that. And then, as Ivan talked about earlier, that was the tuning tool, but we also have an example here of an end user interface. So many headphone manufacturers are also, let's say, we're all learning about what is, how spatial audio will be rolled out. And so this is a proposal we have for how an end user interface could look like. And over time, as end users get more used to it, we can easily add more features. So, switching on the spatial audio, for example, here, the end user is able to switch their head tracking on off, decide, are they very active, in other words, running around, or are they actually relaxing in front of a TV? But also, they can change the sound stage, how wide the sound is, but also how much room sound they have. So these are just a few settings, and they, of course, relate directly to the underlying tuning tool.
So I just want to say, so the reason that we came out with this tuning tool was that, it was a great discussion to have with the R&D, like we are the geeks in audio that kind of like, oh, I can do all this. And the second they came into market and they go, yeah, I'm just going to do an on-off switch. So end users get their headphone on, turn on, like, I don't like this, and they shut it back off. Yeah. And I think what they saw was most of these guys never shut it back on. Like it was just off forever, or it's on forever. And what we wanted to create was a way to kind of have brands go in multiple directions. So one way is to say, well, I want to do use case basis for the user. So if they're listening to a podcast, we have a certain mode. If they're listening to music, we have a certain mode that we can then totally independently tune and set up on like head tracking, speed, and all that. But it might also be that they just want one preferred setting that then goes with everything. So having set all this up allows them to do this. So the package that we send to the marketing department is, this is an API. All you need to go down is into your app developers and say, send these APIs to the engine, and you can basically set this up in your own. So one of the things we particularly heard was the head tracking. When I walk around, and I do that, I actually use these for just walking around the city. And what happens is, when I turn a corner, the sound sticks in the corner, and then like it stays out there until it kind of realizes that I've actually made a change in direction, and then the sound kind of comes swooping around. And what we can do here is I can set it in active, which means that it basically, as soon as I leave a certain degree that I define, it recenters on me. Meaning that if I walk around, the sound is not going to stick. It's going to follow where I look, and it's going to actually I'm still going to have the mic of movements that gives me that externalization, but it gives me a way to kind of follow around. And I think that's one of the things we initially heard from some of the other integrations, that the sound was slushy. Like you turned your head and it kind of stuck out, and then I turned my head again, and then it was over here, and there wasn't really a focus on it. So again, if I'm sitting still and I'm watching a movie and I look to the side, this is still my content. I still want the content to stay here. I want this spatialized. So that's when I'm relaxed. But when I'm out walking around, I actually want the sound to stay in front of me. So I think these are some of the settings and some of the discussions we start having with product managers, product marketing, those guys, that just extends the usability of the technology and take it away from that kind of on-off switch. Do you like it or do you not like it? Into saying, if you don't like it, what can you do to actually like this or get it closer to your preferences?
Okay.
So I think one of the things that I mean, when we go out, and what we spend a lot of time on is, when we initially went out, we talked to brands, and they were kind of like, oh, this is cool technology, but like, how do I get this in my product? And that was a long discussion. I think we all know that headphone brands, especially those at the higher end of the spectrum, they're very meticulous about their solutions. They're very meticulous about what it is, and that's what you pay for. So a process to integrate something on a headphone takes a lot of time. And to kind of short circuit that a little bit, we started building relationships first with chipset platforms like the ones that you see here. So basically going out to Qualcomm, Aroha, and Best, and making sure that they knew who we were, that we started implementing on our own, so that when we can start up a project now, we can actually go from first meeting to product in about 6 months, implementing everything. Obviously, Simon, you alluded earlier, IMU sensor, they're tricky. It's a new sensor. It's something everyone is learning to work with. We've got some tools to help you on that. Like what's the sensor actually inputting into the engine to kind of help you? Is it oriented correctly? So we can help customers with that. But that's certainly been a learning process from a lot of partners to find out, once I put it in, how do I interpret that data? So we help a lot of customers with that. So and another one is that we worked with our Sonical and Bragi, good friends of ours that kind of take it into a different direction, saying if you've got a preferred sound that you like, how can we add that on top without the brands themselves having to be involved? Is there a way to kind of work on an operating system that allows users to then choose these kind of advanced features? So we're supporting those two brands as well. And then, of course, the way that we look at it is that we've embedded ourselves into the audio industry. So we typically talk to the headphone brands and said, hey, here's our technology. That goes, sure, but I don't know where to go. So what we started doing was build relationship with, first of all, the ODMs in China and Taiwan, making sure that if a customer runs into Mary, Minami, your grandson, well, then we have our solutions there. They all have demo equipment that they can go out and show customers. They can't tune yet, but obviously that's something that we're going to go towards. We cover kind of the main high-end chipsets like Qualcomm or Rohan Bez. You mentioned Geely. Obviously, that's one of the ones where, like, when do we dip our toes into taking the next plunge into those? Synaptics is definitely also one that we're building relationships with. So kind of making sure that we became choosable, you might want to say, of saying there's an easy path to a solution here. On CES last year, or this year actually, we were on 6 different suites where when customers came in to talk to these brands, these ODMs or these chipsets, of saying, how do I get spatial audio? They could pull up our solution saying this is an easy path to do something. So I think that really means, and we're adding more and more of these ODM brands, not by the day, but at least by the month, of extending our reach into that market. Yeah. So obviously there's a lot of like future applications that we can go into. That's going to be like the next steps of where our technology go. I think right now we're focused on the headphone market and making sure that works, because that's kind of where we have the edge of doing something which is really small package, power efficient, and doesn't take up the MIPS that makes the engineers go crazy. Yeah.
Okay. No, I think that's a pretty good overview for now. We could always come back when you have your next product announcement and save it for another day.
Yeah.
But, Simon, any parting questions before we wrap it up today?
Very good, I think. It's
okay. All right. So yeah, encourage everybody. Check out the links below. We'll put some contact information if you guys want to look into incorporating this into a future product. And so, yeah, Ivan, Pauli, thank you so much for taking the time today. We appreciate it. And of course, everybody like, subscribe, and share, and we'll see you on the next episode. Thanks, everybody.
Thank you.
Thanks
a lot.